we can prove the Cauchy-Schwarz inequality given two vectors x and y in Rn. Then the absolute value of the dot product of x and y, so x dot y absolute values less than or equal to the norm or the length of x times the length of y. So here's the absolute value, because this is scalar, right? We know that this scalar product is scalar. The absolute value of this scalar less than or equal to the length or the norm of a vector x times the length of a vector y. And to prove Cauchy-Schwarz inequality, we will use a theorem that we proved before about the angle between two vectors. By the way, Cauchy is a French mathematician. Schwarz is a German mathematician, and this inequality sometimes you also call Cauchy-Schwarz and Bunyakovsky inequality. Okay, so we will use one of the theorem we proved before about the angle between the two vectors, which is this one. So recall that we have this theorem. The angle between two vectors x and y is equal to length of x times length of y times cosine of theta, where theta is the angle between x and y. Okay, now we have the left hand side is absolute value of x dot y, which is the absolute value of this one, right? So these are all real number, right? Actually, this is positive, this is also positive, right? And this number is between -1 and 1, right? So this gives us, so absolute value of this is norm of x, because this is onward positive or non-negative. This is on also, and since the cos of theta is between -1 and 1, so it's absolute value of cosine of theta. Okay, cosine of theta is less than or equal to -1, which gives the absolute values less than or equal to 1. Right? X times y times 1, right? And therefore this is not length of x times length of y, which is the Cauchy-Schwarz inequality we need to prove.